Okay, we continue to have problems with volume, so we're back with the headphones. But we're talking about 7.4 today, which is the transformations of your exponents and logs. I know y'all all have your book on the internet all the time, so you don't really get to see how much progress we've made, but look at that. We've been through all of these pages, and now we just have this left. And it's not even all of that, because these are like selected answers. So we're like pretty close to being done. So that's kind of exciting. Just a bit of like, I don't know, visual acknowledgement, I guess, of just how far and how much we've learned this year, hopefully. Okay, so as far as it goes with transformations, you know, we could write this whole section here all over again. But personally, we've written it for all sorts of functions, right? We've written it for your absolute value. We wrote it for quadratics. We wrote it for whatever graph we learned in chapter 4. Let's just look at it exactly. What did we... So we learned it in absolute value and in linear. Chapter 2 was systems. Chapter 3 was quadratics. Chapter 4 was nonlinear systems and quadratics again. We learned it for polynomials. We learned it for exponential and or just exponents and radical functions, right? We did some transformations there. So now that we are in exponential and log functions, we are back with the transformations. So I just don't want to rewrite this chart again. You know, we've had it so many times. We understand that horizontal transformations are inside parentheses, vertical are outside, reflections over the y-axis is just the x that's negative, over the x-axis is the whole equation that's negative. We have our horizontal stretches and shrinks, and we have our vertical stretches and shrinks. We get it. If you don't get it, maybe you need to copy this down again. But hopefully we don't need to copy that down again. So my first thing that I'm going to write is just say C chart on page 370. We've copied it for almost every chapter. We should have it ingrained in our... Ooh, that's not R, that would be out. And it stopped recording. Maybe it didn't, but it just froze. Okay. Ingrained in our brain. Okay, it says it's still recording, but this thing is frozen, so I'm going to reload it because it's just struggling. Interesting. Okay, 10 minutes later, we're there. Okay, so ingrained in our brain, we should have that done, right? We should have that chart memorized. So instead, I'm just going to work on examples in here. And y'all have been really liking doing it on page, this one, and 372. Sorry, 370 just has your exponential graphs, and then 372 has your logarithmic graphs. So it's the same chart, but if you want to just see examples with that in there, great, go for it there. Okay, so then for your homework, I'm just going to do some homework problems. It was 3 through 30. 3 through 30 multiples of 3. What page is this? 374. 3 through 30 multiples of 3, and then 35 through 41 odds. Okay, so 3 and 6 are matching your equations to the graphs given. So I'm just gonna show you that so that way you can visually see what we're talking about. Here we go. So 3 is x minus 2, x plus 2, and then minus 2. So we're gonna shift it 2 units to the left and then 2 units down. So I need an exponential that's 2 units to the left and 2 units down. So that to me looks like it's going to be option C. Okay, and then 6 is 2 units right and 2 units up. So that would be option B. Great, that was easy. Okay, so then in the next set of exercises, you're going to describe the transformation and then you're going to graph each function. For the graphing, graph it in Desmos and then copy it onto your paper. So I should see graphs on your paper, but you don't need a chart. Just graph it on Desmos to get the look of it. Sometimes when y'all do that PS, you just say, there it is. And that's really ugly. And doesn't tell me anything. It doesn't show me the asymptote. It doesn't show me any characteristics. There's clearly not a y-intercept. So if you could at least get the basics shown. So like if there's a y-intercept here at positive 2 there, then I need to see a y-intercept at positive 2 on your graph. I don't need every point, but I need the main ones, you know? So a y-intercept and your asymptote labeled, then you can call it good. Okay. Share that with your friends if you are a person that watches these videos, because I know not all of you do, and that is to the detriment of your own problem. Okay, so 9, you just start off with your E function, right? Euler's number raised to the power of x. And then your transformation now says you have Euler's number minus 1, so it's just a translation 1 unit down. Easy peasy. So then you'd have 12 next. 12 is easy. You can do that on your own. Then you have 15 next. 15 could be complicated. So 15, you have f of x equals 1/4 x, and g of x is 1/4 x minus 3 plus 12. So remember, I'm just talking about the transformations. So from this to this, it's the minus 3 and the plus 12. So we translated 3 units to the right and 12 units up, followed by your graph. Insert graph here. With y-intercepts and asymptotes labeled. Okay. Oh, it's like a wild L labeled. Okay, so that's 15. Then you would have 18, and looky there, we're still describing each transformation and then graphing. So congratulations, you get to do the same thing. So 18. Okay, so for 18, you have f of x equals e to x, and g of x equals 4 divided by 3 e of x. So if this was a horizontal stretch or shrink, your 4/3 here would be the coefficient of your x, right? But it's not. It's the coefficient of your e, so that means it's going to be a vertical one. And remember, your verticals are bigger than 1 and less than 1. So 4/3 is bigger than 1, so therefore it's going to be a vertical stretch. So we'll just say vertical stretch by a factor of 4/3. And then you would also insert graph with your y-intercept and with your y-intercept and your asymptote. Beautiful. Okay, and then we only have to go to 30, and like, dang, we're almost there. So, oh gosh. Okay. So that was 18, 21, 21 would be interesting to see how y'all solve that, so I'll leave that. 24, same thing. Okay, and then 27, again, it's the same instructions. They love to just keep using the same instructions. 27, now you're with logs. It's the same thing, but it's transformations of logs. So I suppose we'll do one example of that. So you have f of x is equal to log of 2x, base 2x, and then g of x is equal to 3 log base 2 of x plus 5. If you notice, I always call this a base. That is exactly what it is called, and it helps you as soon as you are ready to translate it into exponentials ever. So if you know that this is your base, then you know translating it to an exponential would be really easy because you still have like that stays the same. Your base stays consistent the whole time. So maybe get in the habit of saying it's a base. Again, our coefficient here is of the whole thing. It's not of just our x, so you know it's a vertical stretch of a factor of 3. And then you have plus 5, so it's 5 units up. Yeah? So you have a vertical stretch by, what is this, 27? Yeah. By a factor of 3 and a translation 5 units. Okay, cool. So same situation. You're just doing the transformation. So I'll leave 30 for you to do with that one. And then we're into the next section of 35 through 41. Odd. Why would I include these? Well, because they look exactly like your test questions that most people messed up, right? They talk about your transformations, but it's in words, so you have to do it in that order. So you're going to move 2 units down, then you're going to do a reflection. So if it's 2 units down, you're going to have 2 to the x, and then minus 2. And then it's a reflection in the whole x-axis, so everything turns negative. So you should have a negative 2x here, and then plus 2. Even though it went down, because the reflection in the x-axis came second. So everything gets multiplied by that negative. So then 37, you have a horizontal shrink by a factor of 1/2. So remember, that's going to become a 2. So now I have e to the 2x. And then I have 5 units up. So e to the 2x plus 5. And then 39 and 41 are logs. So same system, but now you got logs. And that will be your homework. So that took me about 14 minutes to get through. And we did it mostly together. So this is what you should be working on Friday, April 21st, or Monday, April 24th. Don't forget about your test corrections due May 5th and May 8th. And don't forget about your take-home test, also due May 5th and May 8th. I will be working on getting another calendar posted so that you have the rest of May planned out.